Essentially, all vacuum cleaners kind of work the same way. The heart of the machine is the motor, because that draws the air through from the cleaner head up the tube, through the cyclone and filter, and then through the motor, and then out through the exhaust. So to get a really good performing machine, you need a high performing motor. And that's where a lot of cordless machines struggle, because they use motors a bit like this, which is a brushed DC motor. And the problem with these is they're not terribly efficient and they spin quite slowly, about 25,000 RPM. So this machine is typical of other sorts of cordless machines you have. So it'll probably have a similar sort of motor to that one in it. And when it's switched on, there's kind of no real airflow being drawn into the machine, and the actual amount of suction is very low as well. You can see how much more suction there is on our machine. For our latest cordless machine, we developed a new motor, V6. And you can see it's much smaller than the conventional brushed motor. And the key difference is our motor uses a digital pulse to create the energizing of the motor. This motor spins much faster, in fact 5 times faster than a Formula 1 engine. So the oscilloscope's measuring the speed of the motor, so you're up 110,000 RPM. That's so fast we had to develop the software to actually be able to measure it. Because it's spinning much faster, we can make it much more efficient. We can make the diameter much smaller and still get the airflow going through the machine. And it's significantly lighter, significantly smaller. So we've designed and developed a motor that gives us powerful suction in an incredibly small and light package. So because we have the Dyson digital motor, the V6, as the heart of the machine, that translates to really good suction down at the cleaner head where we're picking up dust from the floor. So if I switch this machine on, we've got fantastically high suction, especially compared with other cordless machines. And that really shows when you start doing comparative tests, looking at how well it picks up on hard floors against other cordless machines and even some corded machines. Let's put down some fine dust and try them out. So it's hardly picking anything up. That's leaving loads behind as well. Much better. So the combination of the V6 motor, the 2-tier cyclones and the carbon fibre bristles means we can achieve really effective fine dust pickup on hard floors. So when we designed our latest cordless machine, we spent a lot of time looking at all the different elements that go in the machine to make sure that we position them right to make it feel really nice and easy to use. We put the motor and the batteries and the cyclone all up at the top and the cleaner head down at the bottom. And because of the way the leverage works, it means that actually the weight is up near your hand, so the centre of gravity of the machine is here. So that means it's quite light in your hand and easy to use. So if I put the weight down towards the end of the rod and then try and lift it up, that's very heavy in my hand. But if I move the weight back up towards where my hand is gripping it, it's then much easier to lift. Other cordless machines are nowhere near as versatile. You have to remove the handheld unit, but then I have to reach right up, though I'm quite tall, or reach right down. It's nowhere near as convenient as our machine. And corded machines are no better. They tend to be heavier in the hand, and then you've got the cord coming with you everywhere. So this one has the weight in the hand, but the whole machine is quite a bit heavier than ours, so it's still not very nice to use when you're trying to go up high. So after you've used it, you have to wind up all that cord. Which again, isn't very convenient. So when you've got no cord, you can just get everywhere. You don't have to worry about anything trailing behind you or knocking anything off a table. It's completely convenient. And then as well as taking the head off and reaching up in high spots, you can use the machine as a handheld. Really quick and easy to use. The vacuum cleaner is designed so that the airflow goes through the head and sucks up the dirt into the machine. So the design of the head is critical to how well the machine works. Now obviously you need really good suction to make sure that you're taking the dust away from the floor up into the machine, into the cyclone. But also the design of the head is critical so that you really get the dirt out of the carpet or hard floors. And that's what this test is all about, showing how well it picks up very fine dust off hard floors. There's almost no dust left, it's nearly all been picked up. Let's try another cordless machine doing exactly the same test. Well, on the sides it's left a strip of dust that's untouched by the cleaner head, and where it has tried to pick the dust up it's left a lot of residue. You can see there's quite a lot of dust still in the cleaner head, which hasn't actually been sucked up into the machine yet, which is just dropping out onto the floor. And also you can see on either side there's quite a wide gap. There's not enough suction at the head to suck the dust in, which is why it's left these stripes at either side. So we have a look at our head. The dust's been sucked straight up into the cyclone. And you can see underneath the design of the head there are two types of bristles on the brush bar. The purple ones are nylon and they're designed to get very good pickup on carpet. And the black filaments are carbon fibre. And they're incredibly fine and have sort of anti-static properties, which means they're very good at picking up the very fine dust off hard floors. Additionally, the detail of the head at either side, it's very narrow, which means the airflow can come straight in from the side, and that picks up the dust right to the very edges of the track, so you're getting full width cleaning. So when James designed the first dual cyclone vacuum cleaner, it had a sort of single large cone inside. But over the years we've refined and developed that technology. This machine has 15 small cyclones arranged in 2 tiers. And because they're much smaller, it means that the air spins much faster as it goes down the small cones. That allows the very fine particles to be thrown out with even more force. So we can make the cyclone pack on this machine even more efficient. We've got fantastically high suction. Most other cordless machines have very simplistic cyclones in them, so they're not very efficient. And what that means is a lot of the dust just passes straight through the cyclone and onto the filter in the machine. And the problem with that is the filter clogs up and prevents the airflow going through. So they don't start off with very much suction, and that suction drops very rapidly as the filter clogs. So we've loaded the machine with 25 grams of test dust, and we're going to see how that's affected the suction. And you can see there's no change, so the suctions remain constant. So you can see the filter's incredibly clean. The dust has been spun out and remains in the bin. So this machine has been loaded with the same amount of dust. Let's see what's happened to the suction. See, nearly all the suction's gone, even though it's only picked up 25 grams worth of dust. So let's have a look at the filter. You can see it's completely caked. That's why the suction's dropped so much. There's no way the air can pass through the filter. So on our latest machine, the combination of the Dyson cyclone technology and the Dyson digital motor means it sucks up as much as a conventional vacuum cleaner without the hassle of a cord.